Hi, and welcome everyone. My name is Cassie. I'm with Vario, and we are broadcasting today from the Vario US headquarters, or I am broadcasting, but we are actually coming from all over. Our panelists will be all over. Thank you for joining today, whether it's your morning, your afternoon, or your evening. We're going to go ahead and get things kicked off here, and I'm going to toss it over to John.
Well, good morning and good afternoon, everyone. My name is John Burwell. I'm the global lead for simulation and training with Vario, and it's my pleasure to welcome you here today, whether you're joining us in your morning or in your afternoon, depending upon where you're coming in from. We have an exciting topic to talk to you about today, crossing the chasm, virtual and mixed reality solutions for training. This is a topic that's been certainly near and dear to my heart for a long time. I've been in the industry myself for over 35 years. I spent the early part of my career at Boeing, Evans and Sutherland. I worked for Silicon Graphics, Forterra Systems, Bohemia Interactive Simulation. So I spent a lot of time working with this technology and trying to provide, technology transformation that would enable the use of virtual and mixed reality technology to provide simulation and training solutions. So certainly in this time, we've seen a lot of fits and starts, but what I'm here today to tell you that we really have reached a point where we're really seeing some real solutions being put together and being used for training. So for example, programs like the U.S. Air Force Pilot Training Next, the synthetic training environment that the Army is working on in the U.S. Is looking very promising for using VR technologies. And other examples of that in the Navy that we'll be talking about today. So what we're seeing here, I've started a long time ago. So my initial exposure to this was when I saw an article in Scientific American about VPL research and Jerry Lanier and the research that he was doing. At that time, I was at Evans and Sutherland. I traveled out to the Bay Area in the early 1990s, and I saw the technologies that they were producing. And where it was very interesting, the helmets were massive. They were heavy, they were very difficult to wear, they were low resolution. The computers were huge. The software was really far from ready, but it looked very promising. And at that time, I thought, well, in a year or two, this is really going to change how everybody does training. Well, here we are 30 years later, and I think we're finally getting to that point because of a lot of investments that many companies have been made and put into this technology. And that's kind of what we're going to talk about today, and we're going to talk about putting those solutions together. So we'll talk about virtual reality solutions where you're totally immersed in the headset, but also mixed reality solutions where you're able to interface and touch with real objects that are around you, but still be immersed in a virtual environment. So we have a really exciting panel with us today with some great experience that I'll be introducing in a moment to talk about these. What we're going to do is we're going to talk about where we feel that this technology is good and ready to use today, and some areas maybe where it's not quite ready yet. Then we're going to actually dive into detail with working with Lockheed Martin and the prepared product to really talk about how you can build these solutions using today's technologies. All along, we're encouraging users to enter questions. So there's a Q&A button on your panels that you can go ahead and select. And you can go ahead and write in your questions. When we get toward the end, we're going to spend some time going through and providing some answers there. Next. So it's my pleasure to introduce our other panelists for us today. So first of all, from Lockheed Martin is Chris Mattel. Chris Mattel is the engineering program manager for the prepared software solution. He's going to be joining us later in the presentation to talk about the solution implementations. And it's my great pleasure and honor to introduce Rear Admiral Joe Kilkenny, who is the former head of naval training. Admiral Kilkenny has a 35-year experience in the Navy, 35 years of combat experience. He was an A6, F-14, F-18 pilot. He was also a carrier strike group commander, and virtually held every human resource job that there is in the Navy, including the head of naval training. So he'll be able to provide us with some fantastic experience there. Also, Admiral Kilkenny, after he left the Navy, he worked for CSX Railroad, and will be able to provide us with some great insights from the commercial perspective of the use of these AR and VR technologies. And so with that, what I want to do is switch gears here and bring in Admiral Kilkenny and talk about the application of these and where there's a good technology fit for providing training with these technologies. Admiral?
John, thanks so much for the kind introduction, and for Vario and Lockheed Martin to allow me the opportunity to participate in this webinar on a topic that I've been following intently for a long time now, and that's modernizing your training. As a former head of training, as John said, for the Navy and CSX Railroad, it's absolutely imperative that those of you in the audience that are responsible for training, you find and embrace new solutions that are productive, relevant, immersive, and cost-effective, that will provide your employees with the training tools they need to successfully apply the knowledge, skills, and abilities required to perform the tasks they are assigned to do. Today, we will discuss and look at this new cutting-edge technology. Thanks so much, John.
Excellent. So, in the introduction, I talked about things being different this time, and they really are different. If you look back to some of the early implementations of VR, what you had was certain technologies that were being developed. They weren't specifically developed for VR and AR, and they were used to cobble together solutions that were thrown together to try and provide these immersive environments. And frankly, they weren't really good. What's different now, and it really started back in 2012 with the acquisition of Oculus by Facebook, is that you have a number of companies, they're providing significant investment into display technologies and other sensing technologies that are specifically designed for this. A good example of this is Vario. So Vario started in 2016. What we're doing is taking the latest and greatest display technologies there, and we're integrating those to produce specific helmet-mounted display solutions that provide, human eye resolution displays that provide the ability to mix real and virtual content by putting video systems on the front of these and providing compositing technology that will enable those signals to be mixed. The displays and all are just part of it. We are joined by significant investments coming from companies like NVIDIA that are producing high-performance graphics technologies like we've never seen before. And so for a small amount of investment, you can buy a graphics card that will allow you to create that the amount of scene content that you need to run at high rates so that you don't get simulator sickness. And you can do that with these standard graphics cards, and that's very exciting. To go along with this, we're also seeing an incredible amount of work that's being done in the sensing industry. And so building sensors that you can use to track your hands, building suits that you can put on that will sense your movement and put that all together. Those are also important parts to this solution, to put that together so that not only can you provide that visual environment, but you can also provide the ability to interact with virtual and mixed reality objects. So companies like Leap Motion or Ultra Leap, they're producing these sensors. That's really important. And then last but not least are software solutions. So if you look back 10 or 20 years, all of the software solutions to build these were all being done bespoke. And so you had a small number of people that were developing custom applications. That was very expensive. It took many years to get it. But what we've seen recently is platforms that are being developed. And a great example of this is what Lockheed Martin is going to be talking about today with their Prepared software toolkit. So with Prepared, you have pre-built flight dynamics, you have pre-built terrain, you have all the elements that you can use to put together to create these high-performance simulations. And Chris Mattel from Lockheed is going to be showing some examples of this later today. And then last but not least, most often these days, you don't work alone. You need to have networking, and you need to have the ability to work together. So with near ubiquitous networking of different technologies, to build simulation technologies where multiple people can work together in the same immersive environment is a critical factor. And some of the software solutions and all the rest of that are there today to support that. So what I'm saying here is that we have, for the first time, a great technology platform that includes both the hardware, that includes both the software. And using these different tools, we can put those together to create both virtual and mixed reality solutions. These solutions won't solve all problems, but there is a certain set that we're seeing today that it's doing a really good job, and some more that we see coming up shortly. So what we want to do now is go back to the experts. We want to shift back to Admiral Kilkenny, who's going to talk about where he sees a fit for these technologies, in the current training continuum, primarily for aviators. Admiral?
Thanks again, John. So I think one of the bumper stickers for this as we look into this training arena is that humans learn primarily by seeing and doing, and that's what this technology brings. So a quick refresher in the virtual world, virtual reality, it's simply that. Everything you see is virtual. So it's a smaller footprint, a smaller unit, probably consisting of a headset, a computer, and some sort of controlling device. In the case of aviation, it's probably a stick and a throttle. In the mixed reality world, you're using the virtual and real views with certain pieces of equipment being virtually combined with real equipment so that the user can primarily interface with certain gauges, dials, knobs to enhance their muscle memory and get tactile feel for the equipment they're going to be working on. We'll be seeing this in more depth. And this is being used right now in the military in a huge way, as John alluded to. The Air Force, the Navy, the Army. So let's talk about some of these solutions. So let's talk about the Part Task Trainer. It's a primary way to train someone how to perform certain tasks, geared on a lot of reps and sets, work with individuals and help them master the skills that they need. These are some good examples there. So cockpit familiarization, let me just talk about that one. So if a young fledgling aviator or navigator or some crew member, wants to get a little more familiar with their cockpit, right now you either get into the full motion simulator, you get into the cockpit, you may have some sort of cutout, or you may have, some sort of other device and even a manual. Well, in the virtual world, you can sit in the cockpit. You can look all around. You can get familiar with where your gauges and knobs are, etc. So if you wanted to get in a real airplane, you would be utilizing one that they may be using for a mission, or maybe it's undergoing maintenance. And if it's in the maintenance phase, I can tell you the maintainers don't particularly care when we want to go out there and just sit in a cockpit to get familiar with it. Some of them you can't even hook up the power, so you can't even go through your procedures and your checklists. So that's the individual training. Crew training. In today's world, many of our multi-mission aircraft do not have training simulation for all their crew members. So for some crew members, the first time they ever even get to use the gears when they actually get in the aircraft. Is that cost effective? No. So now we can create a simulated station for all crew members, because that way it gives them an opportunity to work on crew coordination, communication, talking with other crew members, and actually go through possibly even some mission rehearsal. And then unit level training. So we can actually train the individual, we can train the crew inside an airplane, or we can train multiple crews. So a section of aircraft can go out and perform together. You can also possibly have someone, say, in a close air support role where you have a pilot and now you have a forward air controller. They can goggle into the same environment and they can go through the procedures to work them through. It's a lot less expensive than putting them out on the range and doing it before they have time to practice it. And I'd like to highlight also the commercial availability of this. This can be used in manufacturing, medical, and I'll use an example from my days at CSX. I carried it over to them back in the late 2009 or 10. We went into what was called virtual welding. So for those of you who weld or train people to weld, it can be an expensive proposition. You have to have welding tools, you have to have equipment, things to weld. In most cases, you have to request permission to actually weld. And now there was a company called Lincoln Electric, which introduced a virtual welding. So you actually had a welding torch, a helmet, a shield, and you actually had a piece of metal and it was hooked up to a computer. So your student could actually weld and they could see firsthand how well they were doing. Did they have enough heat? Were they in a steady stream flow, smooth weld? Was their arc okay? You can have another student observing in the background and watching how his fellow students doing. And what was amazing about this for me is many of my master welders were not real keen on this technology until we allowed them to get in there and fool around with it. And once they got on there and started using it, many of them, after they used it for a while, they came back and in all honesty, they told me, you know, sir, with all due respect, I realized there were certain things I was doing in my welding up to this point that weren't quite correct. And now I've been able to correct that by the use of this simulation. So as you can see, there's many other opportunities to use this across the board. And so I look forward to having some other discussions, and now you're going to see some of those other options available to you.
Admiral, I know that within the Navy, we've had a lot of issues with accidents in the Pacific AOR. We also have surface training requirements in that. Can you talk a little bit about the application of VR and AR for sort of non-flight applications in the surface community?
Sure, absolutely, John, and that's a great point. So driving a ship requires a crew. So you can literally put your ship anywhere in the world. You can put as many other ships into the same area you're operating in, and now you can goggle in a crew so they're all looking virtually out at what they see out there, and they can practice their crew coordination and their coordination. A lot of the issues we have, particularly across the board, and it's written and it's public knowledge, is many of our mishaps are due to a lack of crew coordination. And so here's an opportunity in a very immersive way, in a realistic way, to introduce a bridge crew to various and sundry situations to see how they respond. So when they get out to do it for the real world, they won't make any of those mistakes.
So one of the big advantages, I think, of this technology is that it's portable. This is something that you can really put out to the point of need. Could you talk about some examples that you might think of where having this technology at the point of need would be an added feature?
Absolutely. So let's say when I was a Carrier Strike Group commander, I would have loved to have a virtual reality Hornet so that we go from point A to point B. The crew members could practice where we're going next and get familiarization flights, weaponeering, anything that they need to practice and highlight. So now you can take it with you. We can't take full motion simulators and you can't do all your training in the aircraft. So now it's an opportunity to make those crew members feel comfortable in the environment you're going to put them in.
Excellent, Admiral. I really appreciate your insights into where this technology can be used. What we want to do right now is shift gears a little bit and talk about how you would actually implement these solutions. And for that, what I'm going to do is I'm going to ask Chris Mattel from Lockheed Martin to join us, where he's going to talk about the ability to build not only VR, but primarily focus on MR technologies, where you're mixing the real and the virtual worlds, and focus on the implementations there for the Vario XR1 headset. During this presentation, he will talk about a couple of different ways of mixing the real and the virtual. One of these ways is using masking technology to create portals, and the second way will be using Chroma Key technologies that allows you to select certain areas where you have a certain color and to be able to key that out to present the virtual world. So with that, what I'll do is I'll ask Chris to join us and talk to us about the prepared product.
Thanks, John, for having me involved today. I'm excited about the advancements being made in virtual and mixed reality. So, as stated, my name is Chris Mattel, and I'm responsible for managing Lockheed Martin's prepared product, basically to ensure it continues to evolve to meet or exceed the ever-changing needs of our numerous users, and ensure that we continue to provide them the highest quality tool available for their training. Prepared is a game-based visual simulation platform that enables users to train and model scenarios in multiple domains. As a focus today is going to be in the air, we also support on air or sea, in space, or underseas. And it can be used for a wide range of the learning scenarios that the Admiral mentioned earlier, including vehicle procedure training, cockpit familiarization, flight planning, air traffic control training, and one of them that's difficult to do in the aircraft, emergency response preparation. With Prepared, users from various industries, from commercial, professional, military, as well as our academic world, have the ability to train anywhere in the world within seconds. This includes over 24,000 airports worldwide that are based on vector data that provides accurately placed taxis and runways. In addition, we leverage this data to accurately display coastlines, lakes, rivers, roads, streams, utility lines, those kind of items that you would often use as visual ground references while up in the air. A great advantage of Prepared is also its free and open software development kit. This has created a large and thriving ecosystem of developers throughout the world who are building capabilities that can be easily added into Prepared to increase its capabilities. This includes aircraft models, high-resolution airports, scenery, utilities, and hardware devices such as the Vario devices we'll be speaking about today. Prepared has been available for almost 10 years, which each release we continue to strive to improve that training experience for professional training to STEM activities for the student. With the introduction of Prepared version 5 earlier this year, we introduced a brand new rendering engine built on DirectX 12. This big leap has laid the groundwork for future enhancements. In Prepared, our engineers can transition more work to better utilize the CPU, the GPU, the hardware to limit CPU bounding and other limiting factors in performance while increasing multi-threaded. Basically, what all that technical jargon is telling you is you simply get a better performance with improved visuals with or without the purchase of new hardware. This new engine enables us also to enhance our visuals. Specifically for this release, weather was enhanced utilizing our enhanced atmospherics, which was powered by Simul's True Sky. By integrating True Sky, we've increased the level of realism previously never seen in Prepared's lineage. With True Sky, the user gets the most realistic sky, weather, precipitation, and clouds possible. This provides you those puffy volumetric clouds and changing sky colors you enjoy on your drive to and from the office each day. They're now within your simulation environment. We've also increased the ways you can experience these visuals by expanding our virtual and mixed reality integration. Prepared has a history of supporting various VR headsets throughout the years utilizing STEM VR. However, version 5 introduced the ability to provide a better experience by including native support for the Vario devices, which includes utilizing the advanced Vario settings directly within Prepared. Vario devices supported include the virtual reality VR2 headset and the mixed reality headset XR1. And we also include support, as you stated earlier, of the masking, Chroma Key, and eye tracking capabilities. With that, I would like to now take some time to begin a video and demonstrate how quickly both the masking key and the Chroma Key can be set up with Prepared in the Vario XR1. This video will show the first few steps required to perform initial setup of these mixed reality options, masking and chroma key. The quick progression will not put you in a production ready state. However, with only some fine tuning within the environment, you'll be set up and ready to go. As we begin our progression into the video, I want to take us to our dome experience. Modern flight training requires a complete training technology suite to prepare our modern day military pilots for their missions. What you're seeing now is a high fidelity dome, which is critical to the complete training technology suite to prepare military pilots for their missions. Through the combination of these high fidelity domes and mixed reality, we have the ability to increase training capacity by matching learning objectives with the right form of technology. As you can see here, this is a high fidelity dome utilizing 10 4K projectors and a set of computers in order to continue to run this product. You have nothing on your head, so you get that full immersive experience as if you were sitting in the cockpit.
So that's the traditional dome environment, and with the full fidelity F-16 cockpit.
That's correct. And what we're going to do now is we're going to transition to how MR can be used to supplement this technology. So as we spoke about early, mixed reality is the combination of some simulated world in a virtual environment, as well as a real world. And utilizing the Vario XR device, we're able to utilize the pass-through camera to populate that real world. And using the prepared software generating the simulated world, we merge those two worlds together and it becomes one world for the user.
So you use the XR1's camera system there to capture video of the cockpit that's going to be in front of the pilot?
Correct. And with the technology now, it moves in real time, so there is no lag between the simulation and what the user's seeing. So as they're moving their hands, they're seeing them instantaneously within it. One thing to point out with this demonstration as well, we're just using a laptop to run it. So we're not using any high-end server. The laptop is running a 2080 card.
So how do you use masking to create the portal? Can you talk a little bit about that?
So within Prepared, we have two aircraft that come with masking already enabled, the F-16 and the F-35, but we have multiple options to create masks. You could add a mask to an existing model by using a product like 3ds Max to mask out the geometry and select parts that you want to use as marked out as not to display the visuals. Within Prepared, we also have a post-process cockpit masking where you can select a camera mode that Prepared itself will find that virtual cockpit that you have and automatically mask it out for you.
So that's what we're seeing here on the bottom. That's a mask that's allowing us to see the video and have that be seamlessly mixed with the virtual environment.
That's correct. So what you're seeing on the top is the virtual world, and on the bottom is the part that's been masked out, which is basically telling Prepared, hey, don't put your visual simulation here. I want to use the camera. And so right now what we're doing is we're aligning those two items and calibrating it. So the Vario device puts the pass through the real world. Prepared is going to generate the simulated world, and it's going to piece them together. So right here, what we're going to do is we're going to align the two together. So make sure that the camera is aligned with the mast in the model. In this particular case, we're just going to use a Xbox controller to quickly align it for this demonstration, but this is where you could use other advanced technologies such as markers to come up with a more specific production ready level of alignment. But you can see how simple it is to get going to that 80% solution, and then you can tweak it from there. So we continue to move it up. See, we just move up the mask to align with the camera, and then when we're happy with it, we'll select it and we'll move forward.
So everything in the bottom of the scene is real, coming from the cameras. Everything on the top of it that's in that cutout is all virtually generated? That's
correct. And we'll show more examples of it running together, but that's just basically a setup. So you can see it's a few steps quite quickly using the menu system. So now we'll transition to another option to support mixed reality is the Chroma Key. So what you see here is we turn the dome into a green screen, which is not your ideal situation because it exposes a lot of green light into the room. However, for this demonstration, it fits perfectly fine. In your environment, you could use a standard green screen, or you could even use something as simple as a sheet. And the green is a color that could be modified to meet your particular environment. So what the green screen does is it utilizes, or the Chroma Key does, is it utilizes similar technology that we've seen in movies that they use for special effects. So what the prepared software is going to do, it's going to look for that green area, and anywhere it sees that green area, it's going to produce its simulated environment. And then areas that are not green, the camera will fill in the content, so you get that real environment. And they blend in seamlessly together. So again, we're just within prepared, selecting the aircraft we're going to choose. Prepared has over 30 aircraft already involved in it, and as I spoke about earlier, we have a large ecosystem of numerous third-party developers who are continuously building aircraft that could easily be added onto prepared. So we'll go ahead and once again recalibrate the origin. So we're looking forward in the aircraft. This is the Vario view, so we're trying to ensure that it lines up correctly. Then we're going to go ahead and enable that pass-through camera. So that's that real-world camera on the XR1. And then we're going to go ahead and go into the thresholds to calibrate the color. So right there, you're seeing it's coming through, and we're going to have the ability to adjust those settings. So you have the ability to change the colors within Chroma Key. So if green's not the color, green is commonly used in movies because it's not in skin tone very often. But for this particular situation, you may not be dealing with people. So you could change it to fit your particular need. And you also have the ability to change the fallout and the tolerance of how that color is transitioned. So this is kind of where your tweaking would be involved to get to that final production state. Right now, we're just going to go ahead and leave them at default, which is good enough for our demonstration of showing the Chroma Key capability. And as we step out, looking back to the front of the aircraft, we're going to go ahead and transition to the final parsed together view. And what you can see here is you have a virtual world on the outside, and you have a real world in the inside seamlessly blended together. So now I want to show you some examples of where this is utilized and what the actual experience is for a user. So we have our pilot sitting in this makeshift cockpit, being able to tactically touch real keys. And when he's looking through his device, so what you're seeing now is actually what he's seeing through the XR1 headset. He could clearly read the map. He could look around in the cockpit. He could hold down his knee board. So you have real on the bottom right half, and on the top left side where you had the mountains and the runway, that's all virtually and simulated. Hey, Joe, how do you think this would help your training environment?
Hey, Chris, this is awesome. I'll tell you, it's absolutely imperative that those crew members get to interact with their knee board, look at a map, read their watch. We spend a lot of time writing down various and sundry things. And so the ability to actually see this, use it in that way is a tremendous leap in technology, which in all honesty, as you all remember, was not available probably about a year to a year and a half ago. So this is a tremendous opportunity to be able to use this. And you could actually take some of the existing aircraft cockpit tubs that you have that aren't hooked up to simulation, and now you could get a Vario headset and actually get on there, and now you have a mini version of a dome simulator. And then when you connect them all together, you can actually do some multi-crew training. So this is really fantastic.
Great, Joe. And what you're seeing now is him sitting in the cockpit getting ready to do a simulated training scenario with a partner. So as he looked to his right previously, you saw a wingman there. Prepared supports the ability for multiplayer, so you could have someone else in the same scenario with you fly in, disperse somewhere out there, not co-located with you. In addition, we also support AI capabilities, so we could have an AI aircraft following you around as a wingman, which is what we have in this situation. But it gives you the opportunity to train at the place that's necessary. So while you may not be deployed yet, you might be training with someone who is deployed. It could be in that same environment, so that when you're with them a few weeks from now, you've trained with them. And you'll also see when we step into the cockpit, you have the ability to interact with the gauges. So you're able to look at your displays. You're able to tactically get that muscle memory. As you expressed earlier, that muscle memory is key. The level of fidelity is on the visuals is enough to read the gauges. You could clearly read the buttons, read the gauges, and interact with that. What's also cool about this mixed reality capability is you don't necessarily need to build out the entire cockpit. You only need to build out those items that you care about. So if there's a particular switch or area in the cockpit that's rarely used or only used in certain emergency situations, only touch this when you absolutely have to. that's an opportunity to just build that out virtually and integrate it with the other devices that you typically touch, such as maybe your MFD or your stick or your throttle, those items that you're kind of engaging with on the regular. So it lowers that footprint. It lowers the ability to focus on what really matters. And like you said earlier, that muscle memory to be able to physically sit in that cockpit and touch something is a separation between virtual and mixed reality. So in a virtual reality, all of your gauges would be virtual. So you'd be able to touch the button, but you don't get that feeling of what the button feels like when you touch it. And that muscle memory is often key.
And Chris, you might want to add there that ask any of the aviators that sit in this device and work out. This is an immersive learning experience that's really pretty incredible. And most of them, you'll see when they're in there, so focused on what they're doing, they're oblivious to what's going on around them outside of the environment that they're in.
That's a great point, and that's the key to training. Getting the trainees engaged and fully focused that it feels real is important, because we want training to be exactly what the final mission is. And the closer we can get those two together, the more successful and the safer that pilot is going to be. So that's the video. Thanks, John, like I said, for inviting me, and I appreciate the opportunity to show what we've been able to do with prepared into Vario devices.
Thank you, Chris. That's truly exciting to see how easy it is to implement these solutions, and it's great to see that you're taking advantage of these various compositing solutions, both the Chroma Key capability, which makes it very easy to mix the real and the virtual, and also the masking technologies to create these portals that that have some great benefits in terms of more portability and not needing the green screen technologies. So speaking of benefits, I thought now would be a good time to go back and do a little review and get some feedback from you on what are the real benefits of using this VR and MR technology to provide training. So Admiral, I'm going to jump back to you and ask you to kick us off.
Sure, John, thanks a lot. So let's talk about cost avoidance. So realistically, we have various and sundry training devices. You might have computer-based training. You might have a virtual reality set. You might have a mixed reality set. You might have a full motion simulator. You might have an aircraft. So to implementally use all these different devices is going to allow more people to participate. And so join them together. I look at this as these things should be complementary. It's all about visual learning and doing. And so it's about reps and sets. Many of our simulators today are overworked and overused. And so a lot of students, we're either training new students how to fly the aircraft, or in many cases, current existing aviators to work on some of their tactics, delivery, weapons, etc. But they're clearly utilized at full max. So here's an opportunity to supplement that with virtual reality and mixed reality devices. Also, the more reps and sets you do, it can increase your training velocity. So the Air Force is using this right now with Pilot Training Next to get more students involved in actually going out and doing things, instead of having somebody talk to them, teach them, or reading about it. We are visual learners and doers. So increased training velocity by getting more students the opportunity to practice with the equipment they're going to be asked to operate. So Chris, what about you and the student engagement? What are you seeing there?
Thanks, John. Student engagement is key for training, as I stated earlier. The more the student is focused on the exercise being employed, and the more it replicates the situation that they're going to have in their mission, is key. Utilizing these game-based technologies and these virtual reality are technologies that are common in the modern environment that we're in right now. So they have that interest from the trainees to utilize. I use an example of soccer because it takes it at a lower level. When my son has practice and training, they'll continually do drill, so they'll know how to do a particular pass or a technique. But it's not until they step up into a scrimmage where they actually kind of replicate the scenario of what it happens is where you start seeing the lights turn on, and you start seeing the clicking in their brain of, oh, that's why that's important, and trying to piece it all together. And that's what virtual reality, mixed reality, and simulation as a whole kind of brings together. It creates that real real environment to take the skills you learn and apply it into a mission scenario. And I think a big key that can't be dropped in is portability and the ability to send the training to the point of need. In the past, trainees would come to a training location or a training school. We want to eliminate the need to do that for all kinds of training and bring the training to the student. So with these smaller devices, we could actually package it up and send it to their home so they could train. We could send it to a ship so they could train. There's not a lot of space required. And so that it gives them the ability to train, I like to say, train anywhere, anytime. And this is an enabler to get us to that point. So to be able to do that is great. Like you said, we have great simulation and simulators that are out there, but this further minimizes some of those ability to be able to train. Particularly when we recently run through this pandemic, training from at home is key, and that throughput to be able to do this anywhere is a lot easier. And since we have this multiplayer capability and ability to interact together, we could be training across the world all together in a single simulation without ever leaving our homes. Over to you, John. What do you think?
And I think last but not least, the one additional point that we have there is that there's a lot of cockpits and other kinds of trainers that are out there right now that don't have visual systems on them. And they were built that way just because they were part task trainers or procedures trainers. And by using this mixed reality technology, what you can do is, for a small amount of money, you can add a solution onto that that's going to turn that tub into almost a full mission simulator, with a full 360-degree field of view visual system. So I think that's an exciting proposition for the training community to take a look at those devices that are out there and look at what you can add and what additional training you could do if you had a visual system on those.
That's a great point, John. You speak about the hardware that's already available, maybe for becoming familiar with the cockpit, but you could take that same thing to a whole new level and add actual more mission training as well as familiarization with the cockpit.
Exactly.
Hey, John and Chris. So, Joe, the other thing is simulation allows us to practice things that we don't want to do for real. So there's probably certain emergency procedures that you really don't want to practice in the airplane. Like if I'm in a single engine aircraft and you want to figure out if you lose an engine, how to restart it, it's probably not a smart idea to go out there in the aircraft and shut the one engine you have off and try and relight it. So there's an opportunity to practice in the simulation world so that those are high risk emergencies that now you can practice. So as Chris alluded to earlier, when an aviator or a crew member is faced with that situation, they know how to react to it and respond to it.
Excellent. So it certainly sounds like there's all kinds of benefits to using this technology. And I think this technology has never been stronger than it has been before. And I'm really looking forward to see, how customers out there are going to apply this to provide a true transformation in training. At this time, we're through the basic material that we had worked up. What we would like to do right now is transition to questions, and it looks like we have quite a few. And so I'm going to throw it back over to Cassie, and we'll see what we can do regarding questions.
Great, thanks, John. So thank you everyone who has submitted questions. We do have a bunch and only a limited amount of time. So if we don't happen to get to your question today, we'll be sending out a follow-up afterwards for sure. So just to kick things off here, let's see, we have one question here. So I think we talked a little bit about it, but the question here says the primary focus seems to be aviation-based training applications. Can you speak to VR or MR simulation solutions for vessel-based training?
Absolutely, we can talk about that. I mean, we see a number of cases right now, particularly for ship bridge training, that they're looking at mixed reality solutions where, using XR1 technology to be able to see the bridges and that, but to be immersed in a virtual environment. And so I'll throw it over to Admiral Kilkenny to talk a little bit about those types of applications.
Yeah, thanks, John. So clearly there is an opportunity to use this on board for ship training. As I said, it takes quite a few crew members to operate a ship. And so crew coordination and functionality between, say, the officer of the deck, the junior officer of the deck, the navigator or assistant navigator, any of those people that are responsible for operating the ship safely, there's an opportunity, instead of having to send them to where the full bridge simulators are, that they could have some virtual reality or even a possible mixed reality set close to their home port, or even in some cases take it with them. I mean, with the software we have today, you can literally load up any port and a crew could actually practice on going into a port that they're going to go visit or go get supplies at, and do this in the virtual environment to practice it before they go do it for real. So absolutely, not only in the aviation, but in land vehicles, ships, medical, manufacturing, car manufacturing. There's so many opportunities to use this. And it's about reps and sets and allowing the folks to do it to get comfortable. So when they do it right.
Excellent.
Great. Okay, thanks, you guys. Let's find the next question here. John, you mentioned how increased visual performance of VR, reduces sim sickness, and there were a couple of questions just about how that can impact, training, longevity, and that sort of a thing. So can you just talk a little bit about how, the current technology is mitigating?
So that's a great question, and I can certainly talk to that. So there's been a lot of studies and looking at what causes simulator sickness, and and a lot of it is pointed to issues of latency and transport delay in terms of producing the image and then being able to transmit that to the goggles and getting that displayed. And certainly a lot of these new technologies that I've developed or that have been developed have helped to mitigate that, but there's a number of other factors. So a recent study by the CEO at Design Interactive showed that one of the biggest issues with sim sickness is related to the interpupillary distance adjustment. So everybody's eyes are spaced a little bit different apart, and so it's very important that you get that adjustment right. Well, what Vario has done in our headsets is we put in an eye tracker, and that eye tracker, as soon as a new person puts that headset on, it will automatically go in and adjust that interpupillary distance to make sure it matches what the user is. That alone has been shown to reduce simulator sickness by about 20%. The other thing we have is we have an active fan on the devices. And so what that fan does is it actually blows air and recycles air away from the user. And so that's a great thing to support long duration missions. The high resolution that's provided by the Vario devices is really critical for eliminating eye strain. So if you're looking at like a screen door effect with a lower resolution display for a long period of time, that can cause eye strain, but with the higher resolution, that really helps. So faster performance, reduced transport delay, interpupillary automatic adjustment, and then last but not least, work that we're doing with the video system on our mixed reality headsets also critical. We have special processing capabilities that minimize the transfer rate from the collection of a scene to transmitting that video screen to the GPU so that it's less than 20 milliseconds. And what that allows you to do is get the most recent video signal into the computer so that you can mix that with the virtual environment. And so without multiple imaging or delays and all that, and making that match up so that you sync the real and the virtual worlds is a critical factor. So there's many different factors that go into causing simulator sickness. We're working hard to eliminate as many or all of those as we can, and we've got to the point now where it's very rare that we see a person go in and use one of these devices and come out with any kind of discomfort.
Hey, John, this is Joe. I definitely want to add to that as somebody that's used these devices from their outset. There was clearly a high opportunity for some nausea and not feeling too well. And I can honestly tell you, with the latest technology that's out there now, I've spent a considerable amount of time on these devices and have completely eliminated any ill feelings that I've had at all.
Excellent.
Awesome. So we've had a couple questions come in also about sort of general setup of these. So one of the questions that came in was, can you describe the architectural requirements of the physical training space needed to support the trainees and trainers? For example, the chroma key backgrounds, lighting, acoustics, etc. And then also, if you can speak to, well, yeah, we can get started. Oh, and then there was a question about, is prepared actually accurate at sea level, and does it utilize 3D wave hydrodynamics? So just speaking a little bit more to this setup, and then some specific prepared details.
Chris, do you want to take a cut at that one?
Sure. Regarding the Chroma Key setup, so the actual display of the screen for the green screen, we could utilize numerous things. I mean, the level of the quality of the screen would impact the level of accuracy and fidelity that you're getting with the display. There are multiple settings to adjust that. So as I stated earlier, there are quality green screens built out there that studios and movie studios use, but even utilizing a simple technique as a sheet or a painted wall gives you a close enough opportunity for training. And within the tool set, there are levels of thresholds that could be adjusted. So you could adjust the color to better align to match, as well as the fallout of when it transitions from one color to another. And kind of those thresholds could all be configured. So it is flexible to do it. So there is no hard requirement of what's necessary. But obviously the better environment you have stood up, the better quality and the easier adjustments will be. Did you have anything to add to John, or you want me to step over to the wave question, the sea level?
Well, I think we can say a few things about the setups, and so you need to have trackers to sense the head position and the head movements, and typically having two or three is really an ideal situation. And what you can do is you can set up three or more of these trackers in a room, and then you can put many trainers in them, so you don't need three per system. So you can put a lot of them in a small space. So we've seen 10, 15, or 20 of these in individual locations that are running on a small number of trackers. So the amount of space that it takes is really you can cram these things together and really get a lot of training out of a small space.
John, really quick, there was a question. Are you saying that you are running the Vario HMD on the laptop? I assume the environmental simulation has its own stack. Is this correct?
No, what you saw there was the Vario device as well as a simulation running on a single laptop.
Yep. So the prepared was driving the HMD all from the single laptop.
Great. Okay, Chris, do you think you want to grab the that prepared question?
Sure. If I remember correctly, you're asking about the simulation at the ground level and with the waves. So prepared has a heritage of flight-based simulation and training, but we have expanded and continued to grow it to support multi-domains, and we've seen we have examples in the past of people utilizing it for those environments. We did with version 5 introduce and integrate NVIDIA's WaveWorks into it. So what WaveWorks provides a more visual representation of the oceans and the lakes. So now you will get wave patterns based on the wind and the conditions in the environment, as well as coastlines with waves breaking.
Awesome, thank you. We had another question come in. So do you anticipate that the services will reduce in-aircraft flight hours with the implementation of VR and XR into the training continuum? The reps/sets make sense to makes sense to better prepare for in-flight. But do you see a change of mindset from in-aircraft mission essential tasks and that which aircrew will actually get credit for in the VR/XR environment?
Boy, there's a great question. So I think that I'm going to say a couple of things, then I'll turn it over to Admiral Kilkenny. But I think what we see here is that these VR and mixed reality devices are part of a continuum of training. And so what we're seeing is that versus some of the traditional instructor-led training and the computer-based training that instructors are now, they're bringing the pilots in and they're just putting them directly into the VR devices. And they start training on their own, and they do that training synchronously. So they learn at their own pace. And and some of them get through it quickly. Some of them need extra reps and sets to get through that. When they get more proficient at that, eventually you get to the point where they do need to jump into the more full mission simulators. But it makes those devices much more efficient. So they actually have to spend less time in those devices. And what we would like to see with this is that they can actually spend more time flying in the real aircraft. So whether this ends up supplementing real flight hours, I think that's a pretty contentious question. There are some good examples that we've seen there already. So for example, one is that there's a lot of multi-aircraft team training that has to be done out there. So to train a pilot to do a mid-air merge, you actually need to have 2 aircraft out there. And so there's a number of sorties that have to go into that. It's very likely that if you could do that in VR mixed reality devices, that you might be able to reduce one of those sorties from 2 to 1 by using and getting them more proficient in the VR and MR devices. Admiral, you have some input on that one?
Yeah. So John, you hit the nail on the head. This is a very contentious subject. Most people join the military to fly. And so they want to get in an aircraft. I think it's depending on where you are and what stage you're at. In the training evolution, there's a certain number of flights you are required to fly in order to successfully get through the syllabus. The simulation could possibly reduce those, like you said. Maybe instead of having 4 flights to do something, if you have some of it simulated, you only have 2 or 3. I will also tell you that when it comes to those aviators that are forward deployed doing a mission, they are going to go fly. That's what they're being asked to do. When they're not flying, they could use the VR, MR solutions to help, as you said, reps and sets to feel more comfortable. But you're over there on a mission, and it's not to fly a simulator. It's to actually get in an aircraft and go out there and patrol, perform whatever it is you're supposed to do. But as I said earlier, there's many times when I'm transiting on a carrier from point A to point B that I can't necessarily fly. So if I can't fly, wouldn't it be nice to have something to supplement and complement the training and capability that the aviators have out there so they can practice, so when they get there, not only are they going to go fly, but they're going to go fly flawlessly.
Hey, Joe, if I could join in there as well. We have seen a story recently out of the U.S. Air Force that part of their transition to get pilots to the cargo aircraft or the electronic work aircraft, they have the T-1 Jayhawk as a middle stage progression. They recently announced that they want to put that entire aircraft out of service and replace it with simulators and simulation training. So they'll move from wings to a simulation training base and then to the final aircraft. So we're already seeing that transition happening within the Air Force, and I think we'll continue to see it going forward. Now, whether it impacts flight hours or not, that's a different discussion, because that is a difficult topic, but it could subsidize it.
Yeah, Chris, that's a good point. I mean, I think there are some organizations that are moving to a lot of simulation, and then you actually get to the aircraft and you've had fewer flights, but some of them seem like they're performing pretty well. I think there's a lot of variables that go into that. But like I said, the key is for those that qualify and get through their training and they actually get out there to their combat ready squadron, they are not going to shortchange flight hours. They're going to go out there because we're being asked to go there and perform missions live.
Absolutely. There's nothing that could replace live training. We're looking to supplement that training to make it safer and easier for the pilots, so they're better qualified to do their job.
Bingo.
All right, well, we are completely out of time for any more questions, but as I mentioned before, we'll definitely be following up with these after the webinar. And I saw there were lots of questions about whether the slides and presentation will be available. We will be sending out a recording afterwards. But thanks, and I'm going to toss it back to John to wrap things up.
So first off, I want to thank everybody for taking the time to join us today. Under these current conditions, it's a very exciting time for us in this industry. We like to call it the sort of golden age of VR and MR training, and what we're seeing is major deployments of this technology, across the training curriculum, both on the defense side and in commercial enterprises. And that's really because we've seen a lot of major advances in all these, a number of different technology elements, from the computer systems to the visual displays, to the software and the sensors, all bringing this together to enable a real transformation in training. Looking at projects like Pilot Training Next and Pilot Training Transformation, on the Army side, with where the synthetic training environment is going, and last but not least, with the Navy in terms of Avenger and some of the other programs that they're doing, we see great application of this technology and fitting that in terms of the right applications, using it where it fits as part of that continuum of training. So we're very excited to be part of this transformation. We look forward to working with you as we see ways to apply this technology to take it to the next level. And with that, I want to thank you very much again for joining. All our contact information is here, so if you'd like to stay in touch, please feel free to use these. I want to send out particular thanks to Chris Mattel from Lockheed Martin for putting his presentation together and joining us today. And last but not least, to Admiral Kilkenny for providing his pearls of wisdom and insights that are so valuable for us in understanding the user needs. Thank you very much for joining us today.